Hello and welcome to Project 152, your weekly specialist exam prep. Now, every week we've been going through questions from the QCAA. If you stick with us the whole time, you'll have done every single one of the 152 questions they've ever released. We are very close to the end. It is week 28 and we're going to go all the way to week 30. If you're watching this in the September holidays, which is when it is released, fantastic, because you're studying exactly as you should be. This is a tech active one. Let's get started. Alright, so here's a nice little question, and it's the second one that the QCAA have ever released that looks kind of like this, where you're supposed to take some sort of population distribution and figure out what the distribution of the sample means would look like. Okay, so let me talk you through the thinking process here. A bunch of information about it, but it says, importantly, the mean number of bedrooms per household was calculated to be 3.5. Now that's important. So something we're supposed to know is that if the population mean is 3.5, we would expect the mean of the sample means to also be 3.5. Now, look here. 50 samples of size 40. 50 samples of size 40. Now, if our samples are greater than 30 in size, in this case they are, we would expect our sample mean distribution to be normally distributed. Okay, so that out of the way, let's take a look. This is not normally distributed. You can see that, so we can get rid of this one. So this one is out. Okay, what else can I get rid of? All right, if something is normally distributed, the mean and the median, the middle point of our normal distribution, will be equal. They'll both be 3.5. And if we look at this one here, the mean, that central value, isn't 3.5. It's 3.4. So we can get rid of this one as well. Now, distinguishing whether this one or this one is the answer, a little tricky, but let me show you. It comes down to this formula right here that we use to calculate the standard deviation, or how spread out the data is going to be. Now you might be looking at this and saying, well, hang on, I don't know the standard deviation, so how is this going to help me? Well, we do know the sample size. So whatever the standard deviation actually is, we're going to be dividing it by the square root of 40. Now the square root of 40 is about 6.5, something like that. So S is going to be equal to 1/6 of the standard deviation of the population. Now look how spread out this is. It's spread out from 0 to like 6, right? Now if we think of that spread and we squash it down by 1/6, divide 0 to 6, divide 6 by 1/6, we end up with 1. So we'd expect that wide spread of our normal distribution to be 1. Here, look here, we're going from 3.1 to 3.9, about 1. Here, we're going from 1.5 to 5.5. It's not squashed up enough. When you take your mean of your sample means, it's going to squash up. And this hasn't squashed up enough to be our answer. So our final answer is D. All right, so with questions like this, you need to look for these sort of properties of populations and sample means, and you sort of have to get a little bit fluffy with your maths. Don't be looking for exact answers. You're supposed to know a little bit about how population turns into a sample mean. All right, let's celebrate that one and move on to the next one. All right, this question is a really deep cut. And so it's not surprising that this is the worst performing question that the QCAA has ever released. When this question came out last year, only 15% of students got the correct answer. The worst question ever done. Okay, so I need to sort of talk to you about what the intention is here of the exam writers, or at least what I believe the intention of the exam writers is. Because I don't believe that their intention is for you to do any kind of calculation with this. And I don't think their intention is for you to do any kind of calculation with this either. The test writers assumed that if you knew your stuff, 5 seconds, and you circle the correct answer. That's how easy this question was supposed to be, and it wasn't. Okay, so what are the test writers trying to do? They are trying to dive into your syllabus and specifically deal with the logistic equation. Now, this logistic equation, it appears here once. Formulate and use differential equations, including the logistic equation. Okay, that's what this is testing. Specifically hidden within the appendix of the syllabus is this little piece of information about the logistic equation. So if we take a look at this little piece of information, it says that the logistic equation can be written as AY minus BY squared. All right, so it can be written as this. This is a logistic equation. You can also write it in a factorized form by bringing Y out the front, and you get A minus BY there. Now, this dy dt in this form appears here within the solutions. So straight away, you're supposed to know the answer because you saw this and that right down the bottom here. The general solution of dy dt in this form, either of those forms, is this, a over b plus ce to the power of negative at. So it's something you're just supposed to know. You're not supposed to do a bunch of calculations. So testing very sort of esoteric knowledge that clearly not a lot of specialist students knew. They did worse than chance on this question in 2023. The answer is D. You can see it takes the form y times a minus by, just with a coefficient out the front. So our answer is D. Last thing I'll say about this question, if you head on over to the website, Project 152, and go down to week 27, down here somewhere, which is last week, you'll see this question here from 2020. This was a big, long question that, again, a lot of students struggled with, but it steps you through the actual process of integrating and getting to that form, that a over b, blah, 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 blah form. So if you want to go back and take a look at that, this was kind of like a precursor to this 2023 question. It was a real toughie back in 2020. It was question 12. It was something that students really struggled with, but it was supposed to be like an easy-ish question. And so, final word, does this mean that the QCAA are going to test this again because they think maybe everyone's learnt their lesson and they've learnt more about the logistic equation, or are the QCAA not going to test it because of how badly students did? I don't know. We'll find out in the exam this year. All right, let's celebrate. So we've got a big question here that tests your knowledge of vectors, essentially. All right, so we have a cube. All right, so all lengths are equal length, and we're going to do some stuff with it. Given OA equals 2i, let me draw that. All right, so given this equals 2i, we're going to determine vector OB. So the vector from here to here. All right, so this is going to be very straightforward because from here, we're at the origin, 0, 0, 0. We've got to move along this line, the y-axis, so that's our j direction. And that's going to be 2 units because it's a cube and we know that that's 2 units. So 2 units in, and we've also got to move along this line 2 units up. So my answer is going to be 2j plus 2k. No I, because we're not moving left or right. We're not moving anywhere in the x-axis, just in the y-axis and the z-axis. So there's a good first step. Vector OB equals 2j plus 2k. We get 1 mark for that. Next question, calculate OA times OB. All right, formula sheet, and here it comes. All right, so if we're going to multiply or do the cross product of 2 vectors, we just follow this rule right here. All right, so OA times OB. OA is just 2i, so it's 2, 0, 0. And OB, we just calculated, is 2j, 2k, so 0, 2, 2. And now I just follow exactly the rules I see here. So the first rule here is A2B3, so 0 times 2 minus 3 times 2. All right, that's simple because that is going to be 0. All right, what about my next one? So the next element's going to be A3 times B1, 0 times 0 is 0, minus A1 times this. So that's minus 4. And then our last one is A1 times B2, so 2 times 2, which is 4. And then minus A2 times B1, 0 times 0, which is 0. So my final answer here is 0, negative 4, 4. I guess we could write it in i's, j's, and k's, since that's kind of how we've started. So just transferred my answer. It's negative 4j plus 4k, 1 mark for that one. Let me get rid of this. So moving on to part C. Consider the triangle formed by joining points O, A, and B. So I've already done that, drawn in this pink line here. There's my triangle, O, A, B. Okay, we're in a three-dimensional space. We're using triangles. It says, use the result from question 14b, so use this answer, to determine the area of the triangle. And so this is pretty bread and butter stuff. We should know that the area of a triangle defined by two vectors is equal to half of the magnitude of their cross product, OA times OB. So that's going to be equal to half of the square root of negative 4 squared plus 4 squared. That's half of root 32. And depending on how good you are with surds, root 32, that's the same as 16 times 2. We can bring a 4 out. 4 times a half is 2. We get 2, root 2 as our answer. Now, do we have lengths or anything? Can't see any lengths there, but it is an area, so it's like units squared. 2 root 2 units squared, that's a 2 marker. All right, continuing on. Let points M and N be the midpoints of the triangle sides OA and OB respectively. Okay, so let's make sure that we draw this in correctly. Point M is going on OA right there, and point N is going on OB. There's the midpoint right there. Okay, and I'm supposed to determine vector M N. How are we going to do that? Now, whenever you're trying to find a vector between 2 points, there's a formula that's probably popping into your head, and that is that Mn is equal to On, the second one, minus Om, the first. So now the question becomes, what is On? Well, On is half of OB. OB is 2j plus 2k, so On is 1j plus 1k. And we can do the same trick for OM, because OM is half of OA, which is 2i, so OM is 1i. So when we do all of this together, 0 minus 1 is minus 1, and 1 minus 0, 1 minus 0, 1, 1. So our answer here is negative 1, 1, or just negative I plus j plus k. Now we come to the last part of our question. Use the result from question 14d to show that the length of AB is twice the length of MN. All right, so here's AB from here to here, AB. Now, we haven't dealt with AB yet. We don't know much about it, but obviously it's equal to OB minus OA by the same reasoning as before. And we know that OB is equal to 0 to 2, and we know that OA is equal to 2, 0, 0, which brings us to negative 2, 2, 2. All right, and we're supposed to use that information and this information in some way. And I feel like it's coming together, because now I can say that AB is equal to, I might write that in i's, j's, and k's. So negative 2i plus 2j plus 2k. And we can see there's like some relationship here going on, because I can factorize this. I plus, actually, negative I plus j plus k. And we can see negative I plus j plus k. That's equal to 2. This here is mn. And we've shown now that AB is equal to 2 times vector mn. Done. A big question, but relatively straightforward stuff as long as you're willing to draw some pictures, have a little think about it, and apply all your vectors knowledge. Celebrate. So we've got a big one here, complex unfamiliar. An object is released from the origin with constant velocity, and this is its displacement function. At a later time, object B is released from this point and travels towards this point with constant velocity, such that its velocity is equal to root 2 times the velocity of A. Okay. Given that object A and B collide, determine the time between the release of the two objects. Assume all positions are given in meters and all velocities are given in meters per second. Okay, where to start? With these sorts of questions, it's hard to know, so you do something. What do I do straight away? Well, I notice that this is a displacement function, and I'm told that the velocity of A is like important because the velocity of A also has something to do with the velocity of B. So why don't I find this velocity? So if you're watching this video, you know how to do vector calculus. The derivative of this, the velocity, is 2 root 3i plus 3j plus 2k. Just found the derivative. Now, in particular, look here. We're interested in the magnitudes here. So let's find the magnitude of this velocity, which is going to be equal to the square root of this squared, and this squared. So this is going to be 2 squared, root 3 squared. So this is going to be 12 plus 9 plus 4 makes 25. The square root of 25 is 5. Okay, so the magnitude of the velocity of particle A or object A is 5. Are we talking meters? I think we're talking meters per second. Okay, and we know that the magnitude of VB is equal to root 2 times VA. So root 2 times 5. 5 root 2 meters per second. Okay, I've made some kind of progress. I've done something. Okay, and then you start looking, okay, well, what else can I do? Well, object A has a function, right? Object B, we're not told a function, but we are told that it's like starting at a point and it's traveling at a point and it has this constant velocity of 5 root 2 meters per second. So that's going to be enough information, I think, to generate a displacement function for object B. All right, so we're coming up with this. It's an object moving straight from one point to another. So the equation of a line, the vector equation of a line, that's going to be super useful for us. So we need A, which is a starting point, and we need D, which is a direction. Now A, the starting point, is easy enough because we're told that it starts from point P. So A is 3 root 3, 6, 0. All right, now the direction, well, we're told that the direction, it's going from point P to point Q. So the direction is just whatever the vector PQ is. And we can calculate PQ by doing OQ minus OP. Let me fix that. So OQ is this thing here, 5 root 3, 8, 4. And OP we already know is 3 root 3, 6, 0. And when we do that calculation, we get 2 root 3, 2, and 4. That, don't forget, is my D value for my vector equation of a line. So I can take this information, and I can take this information, and I can put those two into a vector equation of a line. All right, beautifully done. We can get rid of all of this now. We don't need this. This is our vector equation of our line. Now, what I can do is put it into the same form that it's in here. So it's going to be 3 root 3 plus k plus 2 root 3 k I, 6 plus 2k j, and 0 plus 4k k. A little bit confusing with the k. Let's turn it into a q. All right, so I've just expanded this into i's, j's, and k's. So I have a displacement function for object B. This is my displacement function for object B. I also have a displacement function for object A. And I've done enough collision questions to know that the way to determine whether two objects collide is to find out when this is equal to this, when the I components are equal to each other, when the J components are equal to each other, and when the K components are equal to each other. So it feels like I can write down 3 equations now. So this is great news because I have like 3 unknowns here. Sorry, 3 equations and 2 unknowns. So it feels like I'll be able to do something with this. Now what I notice is this 4q equals 2t, the third equation, it just looks the easiest, right? Because I can divide both sides of this by 2 and I get 2q is equal to t. So I get a nice little relationship here, but let's understand what this relationship is. This relationship is saying that the k components will be equal when t is half of q, right? And I can write it q is equal to t over 2. So we can take that information and sub it into one of these equations and keep moving forward. All right, so I'm choosing to sub it into equation 2 just because it looks simpler to deal with than equation 1. 6 plus 2 times t on 2, that's 6 plus t equals 3t. That's 2t equals 6. That means that t is equal to 3. Now this is like some sort of miracle work here, but what we've done is show that these two objects are going to collide at time 3. Now, how do I know they're going to collide at time 3? Well, I'm told that the objects collide. I'm told that with certainty the objects collide. And I've also found that they have the same, this is their J component, they have the same J component at time 3. And only at time 3. That's the only time they have the same J component. So if that's the only time they have the same J component and they definitely collide, then they must be colliding at that time. Time equals 3, that's the collision. So while we know that they collide at time equals 3, that still doesn't really tell us anything about the time between the release of the two objects. It's not going to be as simple as saying, well, q is equal to t over 2, so 3 over q is equal to 1.5. No, because q is not a speed like a velocity in meters per second. It's kind of a speed parameter, but it's multiples of whatever this value is here. So that's not useful to us. So instead what we can do is find the place where they collide, because we know that the object started in a particular point. If we can find where they collide and we know the velocity of the object B, then we'll be able to find out how long it took it to get there. Let's not get ahead of ourselves though. The next logical thing to do would just be to find where they collide. So let's let t equal 3 in this equation. So by subbing 3 for time into our displacement function for object A, we get a collision point of 6 root 3i plus 9j plus 6k. Great. Okay, let's think about object B for a second. It gets to this point eventually to collide with object A, but it started at that point here. So if it got to that point and it started at that point, and we know that its velocity is 5 root 2 meters per second, we can essentially boil this down to a speed equals distance over time formula. So if we take P to be the starting point of object B and C to be the collision point of object B, we can find the arrow PC, the vector PC. And that's 6 root 3 minus 3 root 3, which is 3 root 3, 9 minus 6, which is 3, and 6 minus 0, which is 6. Okay, so our object B has travelled from P to C, which is the collision point, like that, and it's that. If I know that length, I've got to be super close. So let's find the magnitude of PC. So it's going to be the magnitude of that. All right, 6 root 2. That is the magnitude that object B traveled, the distance that it traveled. Let's think speed equals distance over time. Because we know the speed of object B. We figured that out ages ago. It's 5 root 2. We know the distance that it's traveling, 6 root 2, and we want to know the time that it took to make that journey. So it's going to be 6 root 2 over t. T is equal to 6 root 2 over 5 root 2. All right, this is really nice. The root 2's cancel each other out. The time it took object B, let me get a bit of space here, the time it took object B to travel from here to here is 6 over 5. How long is that? That's 1.2 seconds. Okay, am I finished this close? The time it took for object A to get from its starting position to the collision point was 3 seconds. The time it took for object B to get from its starting point to the collision point was 1.2 seconds. So if they collided, how far apart or how much of a head start did B give A? It's going to be 3 minus 1.2, which is 1.8 seconds. And there is our final answer. Object A took off. 1.8 seconds later, object B took off. It took 3 seconds for object A to get to the collision point. It took 1.2 seconds for object B to get to the collision point. They smashed into each other. Done. What a question. Celebrate. Last question here, let's get into it. It is proposed that the following expression is divisible by 1 plus cis theta for all positive integers. Okay. And then we've got this fancy thing going on here. So that is always divisible by 1 plus cis theta, or at least that's what's being proposed. Evaluate the reasonableness of the proposition. So this feels like proof by induction. So let's get down to proving this by induction, proving that this is divisible by this. First step, base case, let n equal 1. So for the left-hand side, we're going to say summation r equals 0. That means we're starting where r is equal to 0. And then it says 2n plus 1. So we're letting n equal 1. So that's going to be 2 times 1 plus 1, which is 3. So that means we're summing all of these expressions where r is equal to 0, 1, 2, and 3. So we're going to be summing 4 expressions here. All right, and the right-hand side, that one's relatively straightforward. We need to show that it's divisible by 1 plus cis theta. So we need to show that this can be expressed as 1 plus cis theta times something. I don't know what, but multiplied by something. If we can express it like this, then we can say that it's divisible by 1 plus cis theta. Okay, let's focus on the left-hand side again. So putting in 0 first, we get cis 0 plus, and then putting 1 in, we get cis theta, and then putting 2 in, we get cis 2 theta, and then putting 3 in, our final step, we get cis 3 theta. Okay, you might have no idea where to go to from here, but you just got to do one step at a time. All right, cis 0. Now, hopefully you understand what cis 0 means. It is a complex number that's making an angle of 0 and a magnitude of 1. So that's right there. It's just the number 1. You can do it algebraically, cos 0 plus sine 0 I, but you're going to get the same answer. You're going to get 1. All right, this is just cis theta. I can't really see anything to do with cis theta, but I can see something that I can do with cis 2 theta. I can use de Moivre's theorem, and I can express that as cis theta squared. Right, I'm just reversing de Moivre's theorem. I'm going from cis theta squared. I can put that 2 in there and make cis 2 theta. Why am I doing it? Well, having a bunch of thetas and 2 thetas and 3 thetas, my mathematical intuition tells me it's going to be better if everything is in theta, theta, theta. So getting that squared out there feels good. cis theta, and I can do the same trick here, cis theta cubed. All right, now, depending on how excited you get about factorization, this next little bit might feel tricky. Why am I thinking about factorization? Because this is expressed as something times something. So I really need to get this in the form of something times something. Okay, you can think of this as, and I'll just sort of do a bit of scratch here. You can think of it as 1 plus x squared plus x cubed. I'm just letting x be cis theta. Now, sort of thinking common factors, mucking around with this a little bit, we get 1 plus x, and then these terms here have a common factor of x squared plus x squared common factor times 1 plus x. Oh, okay. Now this is nice, right? Because I've got a 1 plus x here, and I've got a 1 plus x here. And that means that I can factorize these as 1 plus x times, now all of this multiplied by 1, and this needs to be multiplied by x squared. Okay, so transferring this thinking process to here, because remember my x's are just cis thetas, this can be factorized as 1 plus cis theta, right? That's what my x is there, times 1 plus cis theta squared. That's it. I've proven it. Why have I proven it? Because the left-hand side equals the right-hand side. So I've proven the base case. I've proven that it's true for n equals 1. Proven left-hand side equals right-hand side. All right, that's the base case. I'm going to remove all of this because we've proven it's true for n equals 1 now. Let's prove it's true for k and k plus 1. All right, so this is my start of my inductive step. Assume that it's true for n equals k. So starting where r is equal to 0, going to 2k plus 1, cis r theta. That's going to be equal to 1 plus cis theta times k. Now careful, k isn't a number. We demonstrated that in n equals 1. K is some function, I don't know what the function is, of theta, right? In the n equals 1 case, it was 1 plus cis theta squared. So k is not a number, it's some function. All right, so we're assuming this is true for n equals k. Now we need to prove that it's true for k plus 1. All right, so we're required to prove that it's going to be true for k plus 1. Now there's one little thing I've left off my formula here because I wanted to do it in front of you. 2n plus 1 belongs here, but it's not n, it's k plus 1. 2 times k plus 1 plus 1, that's going to be 2k plus 2 plus 1, that's going to be 2k plus 3. All right, so what we're required to prove is this. We're required to prove that the sum from 0 to 2k plus 3 of cis r theta is equal to 1 plus cis theta times m, where m is in the set of functions of theta. So breaking this up into its left-hand side and into its right-hand side here. So the left-hand side is a really interesting thing. And this is where students are going to struggle a little bit, right? Because here you've got to really interpret this summation and what it means. So 2k plus 3, so we're going to sum r is equal to 0, r is equal to 1, r is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to whatever value 2k plus 3 is. Now look at what our assumption was. We were assuming that it was true for 2k plus 1. That is, we're assuming that 2k plus 1 is equal to 1 plus cis theta times some function of q. So what that means is that we can sub this in here, 1 plus cis theta times k. And then how many more terms are we going to have after that? Well, we're going to have 2 more terms after that, right? Because this was up to the 2k plus 1th term. And so now we need the 2k plus 2th term, and then we need the 2k plus 3th term. That's some terrible language, but relatively straightforward because now we're just subbing in cis. Instead of r, we're going to sub in the next value after 2k plus 1. So 2k plus 2, and that's going to be multiplied by theta there. All right, bit of a mess because you end up with 2k plus 2 times theta. And then the last term is cis, and the last term 2k plus 3 times theta. Okay, so what do we have? We have 1 plus cis theta times k, where k is some function of cis theta. We have cis 2k plus 2 times theta, and we have cis 2k plus 3 times theta. Now, where you go from here, you might make a few mistakes. You might take a few different detours trying to find the right way to go through it, but you do something, you try it, and you see if it starts leading you in a direction where you can start factorizing. But it doesn't seem like a crazy stretch to think that we can use the exact same techniques that we used for showing that it was true for n equals 1. So that is 1 plus cis theta times k, and then turn this into cis theta all to the power of 2k plus 2. And then turn this into theta all to the power of 2k plus 3. All right, this looks like we're done. It feels like we're finished because what do we have? We have a cis theta here, we have a cis theta here, and we have a 1 plus cis theta here. We're trying to get to this 1 plus cis theta idea. So if you're looking really carefully, these have a common factor. 1 plus cis theta times k. These have a common factor of cis 2k plus 2. Or cis theta times 2k plus 2, right? And then if we multiply that, we get, well, what do we need to multiply this by to get this? Just the number 1. And what do we need to multiply this by to get this? Cis theta. Whew. 1 plus cis theta times k. 1 plus cis theta times this nonsense right here. So we can factorize because we have two terms, both with 1 plus cis theta in them. 1 plus cis theta multiplied by k to make this term plus multiplied by cis theta to the power of 2k plus 2. This is some function of theta, which is what we assumed m was here. So we can say that the left-hand side is equal to the right-hand side. And you can finish it off with a little statement. It's true for k plus 1. Therefore, by mathematical induction, is true for all of the positive integers. Celebrate. So that brings us to the end of another Project 152, and that is actually the last tech-free one we will ever do. We've got 2 weeks left, 2 tech-active ones, week 29 and week 30, and then we will have done all 152 questions. Go to the link in the description, download the questions, get started. I'll catch you next week.